Then I will share some of my recent research progress and some most significant contributions we did here. And then as a researcher, how we look at these to address these challenges in a long term and in short term. How I look that what should be doing. When I say long term means how we will be looking at in next 20 years about these challenges, how we will be tackling these challenges in next 20 years. And when I talk about short term, that means what should we do in next 5 years to address challenges related to massive connectivity. Okay, so moving on the first part, I am assuming while talking about this thing is that you have very basic knowledge what Internet of Things are. So it is basically a brief introduction of IoT technology. So when we say IoT, previously the current internet which we are using, we can call it as Internet of People, not Internet of Things. Why I am calling Internet of People? Because people are connected with each other. For example, even if we are using social media, for example, Facebook, WhatsApp, or any other social media or any website, ultimately people are talking with other people, right? So we cannot say that things are connected with each other right now. So what we call Internet of Things is intelligent connectivity of things which is beyond people, in addition to people. So what these things are, things can be everything and anything. Let's take an example of this city where we can see that we have transportation system, parking management system, we have power distribution, we have housing here. So if we go within one house, and let's say we can see there are many appliances here. We can see heating and cooling control. They can be smart, IoT based, smart meter and display systems, smart appliances. Let's take an example of simple refrigerator. So if we take an example of refrigerator, the point is, if we want to make it a smart refrigerator, what we need to do? First thing, we need to equip it with some sensors, which can measure something inside. Maybe it can be camera sensors. It can be a weight sensor. For example, we can deploy a weight sensor in the butter tray. If the weight is less than this, that means we need to order the butter. In addition to that, we need some computation capability where we can compute data coming from sensors, and then communication capability. That means we can communicate that data, process data to someone. So for example, in future, how we will be looking at smart refrigerators, let's say if I have a weight sensor in my refrigerator, and I would say that it's a butter tray. If butter weight is less than threshold, what my refrigerator will do, it will automatically place an order online. Okay, deliver my butter for this home. What is available in the market right now, recently Samsung, LG, and these big brands, they launched many different smart type of refrigerators which can be connected with their other appliances. For example, which can be connected with their washer, dryer, and several other appliances. But the key limitation is Samsung devices can only work with the Samsung devices. It's not possible that Samsung devices can connect with LG devices, which really a big limitation from user point of view, because user is restricted to use only one type of brand for all everything. So some questions are coming. Okay. Anyway.
Not yet,
Okay.
sir, not yet. We will take question answers at the last one.
Okay. So this seems to be one challenge that what we want is we want these devices to be interoperable. So I will talk about this later as well. Why it's not moving? Okay. So there are basically, as I said, there are three main components of IoT. One is we should have some type of sensors. Now, these sensors can be in physical space and can be in cyberspace. Not necessarily we are talking about temperature sensor or GPS sensor. It can be data can come from WhatsApp, Facebook, Twitter, and from any cyberspace as well. So what happens is this result in unprecedented amounts of data. That means we have a huge amount of data to handle. Now, this is one of the challenges, that how to handle a large amount of data. Now, moving forward, uh, as I said, that after sensing, we must have something to compute it. And after computation, what we want is we want to communicate it. Now, depending on the type of system, for example, if we are talking about smart homes, we do not need long range communication capability. So in that case, we may be fine with the Zigbee, Bluetooth, or even Wi-Fi technology for connectivity. In some cases, for example, in the case of smart metering, where we need to transmit a small amount of data to a long distance. In that case, we may prefer LoRa technology, Sigfox technology, because they are low power and long range technologies. For high power and long range technologies, we have LTE, that means 4G, 5G, and now people started talking about 6G as well. Now, the key difference between LoRa and 5G is basically cellular technology is inherently designed for broadband communication, for data hungry applications. It is not designed for a small amount of data transmission. However, in some cases, as I mentioned before, in the case of smart metering, when we have a small amount of data to transmit, in that case, we will be wasting most of the packet space in the case if we start using 5G technology or 4G technology. So in that case, maybe LoRa or Sigfox are more appropriate. So depending on the type of application, we can choose which technology is appropriate, right? Another challenge we are facing, or we need to tackle with is, for example, if some device is using Bluetooth technology and another device is using Zigbee technology or cellular technology, how they can communicate with each other. Systems should be interoperable. They should, regardless of what technology anyone is using, they should be able to talk with each other. So this is one of another challenge we are facing. Then what to do with this data? I mean, once we have all this data from cyberspace, from physical space, what to do? We communicated it to the data center. Now what to do? Now we can analyze data. So data can be analyzed from at different levels. For example, it can be descriptive analysis. What happened? In a situation, we need to determine what happened. That incident has already happened, and we just describing through the data collection, the collected data. Then the second type is diagnostic analytics, which is to analyze why it happened. So this is a good example is the current situation of COVID-19, that if we have a lot of data available about patients or incidents from where it is originated. So what happened, why it happened, how many people are affected, why it happened. And then if we go one step up, predictive analytics is that what will happen in the future. We can predict based on the data that, for example, now people are predicting that, okay, in next month, there will be this much cases for the COVID-19. And then a further step forward is perspective analytics, that what actions to take in order to mitigate it. That's the most important thing. Since if you notice, I make this arrow going upwards. What does that mean? If we are moving from descriptive analytics to perspective analytics, complexity is getting high. We need to spend more computational resources to do the perspective analysis as compared to descriptive analytics. Now, IoT has several different applications. People are talking about smart housing, intelligent buildings, energy savings, and applications are endless. For example, one can look at other things, smart waste, smart green infrastructure, and many more applications can be there. I will not go into the details of these. However, the thing is, this has basically three main implications from the government point of view. For example, one is, okay, I will talk about smart cities later. Let's talk about three major benefits what we can achieve from IoT applications, which are established facts. So for example, in terms of cost saving, the forward-looking governments, they are already deploying IoT technology. For example, in Finland, they used sensors in the garbage cans, which can send them signal when to pick up the garbage. For example, here in Canada, they have 1 or 2 days, the city management has 1 or 2 dedicated days planned to pick up the garbage. Either it is full or not. So depending on the time of the year, sometimes it may get full very quickly. Sometimes in the holidays time, people are traveling, it may not get full. So what they observed in the Finland is it resulted in 40% savings in waste collection. So which is a huge saving. In terms of new revenues, what in US, New York City, what they did is it's a very simple idea, which every country can do. They displayed this interactive smart screens in the whole city. So based on the citywide sensing, communication, and response network, they provide some information to the citizens as well as they generate revenues from advertisement, right? So very simple idea. They are displaying temperature information, humidity information, when you are expecting rain, where the traffic is blocked or not. For example, in Canada, in winter, as you know, winter is very harsh here. So if you go on the highways where in summer that speed limit is 120, in winter, depending on the weather, it can be 60, it can be 80, it can be 100, or it can be 120. So basically, if the system is working automatically with the help of sensors, it can communicate with the people on the road. Then citizen benefits for the citizens. In France, nice city, they nowadays many cities or many countries are using this smart parking systems. So they alert drivers about the open spaces. So with the potential to reduce the traffic congestion by 30%, especially in the big cities, I'm sure in India, Bangalore, New Delhi, and other cities, and also here in Toronto, Vancouver, traffic congestion is a big problem. Sometimes if you go into the downtown, you may spend half an hour, 1 hour just to find a parking spot, right? So what you can do is with the IoT technology, you can book a parking spot in advance, or your system is telling you that where the parking is available, and then you can book. And this not only generates more revenue, it also reduces CO2 emission. So in nutshell, we just looked at three types of benefits: cost savings, new revenue, and citizen benefits. There are plenty of other benefits. Now, for example, in terms of smart cities, when we talk about smart city, what does it means, smart cities? Now, what is happening in the traditional cities, the government or city government is providing is holding basically infrastructure, and why they are holding infrastructure to provide services. For example, city governments, they have city government or provincial governments, they have this energy companies. For example, we have here BC Hydro, provincial level BC Hydro company. They have their infrastructure and they are providing services to the citizens or customers or residents. Now, what we want to do is, if we just add one more layer in between the services and infrastructure, that is data layer. Data layer comes from IoT because data will be collected through sensors. So in that case, what will happen is this IoT layer in between the services and infrastructure, it will provide smart infrastructure management. For example, when to update infrastructure, when to do service, when to do maintenance of the infrastructure, this type of information. At the same time, what it can do is it can provide services. Sorry, I moved in the reverse order. At the same time, it can offer smart services to the citizens. For example, in the case of BC Hydro, British Columbia Hydro Company, as a customer, I can see that how much energy I consumed in one day. Not only that, how much energy I consumed at what times. At 6 a.m., how much was the energy consumption? How much was the energy consumption at 7 a.m. and throughout the day, I can see my pattern. So this really helps me to find, okay, for example, in the peak hours, I should not turn on my washer and dryer things, this stuff. Also, at the same time, what BC Hydro started doing recently, they usually have 1 year challenge. They give customers 1 year and they say, if you reduce your energy consumption by 20% in this year as compared to your last year, what we will do is we will give you rebate. We will give you $100 or $200 things, right? So just to give an incentive to customers, at the same time trying to manage energy efficiently. And there can be many other examples in the case of transportation, in the case of energy, and there can be several other examples in the smart cities. Now, this results with the data layer in between the infrastructure and services, this results in a smart city. Now, when we say smart cities, they are enabled by IoTs. According to Cisco Consulting Services, they say that IoT could generate $4.6 trillion in value for global public sector by 2022, just like 2 years from now, through cost savings, productivity gains, new revenues, and improved citizen experiences. So that means there is a huge potential of this technology. Now, one of the things I talked about while giving example of refrigerator, that what is happening right now with IoT, for example, if some company is developing building solutions, smart building solutions, so they have their existing infrastructure, they have dedicated devices for smart building. Similarly, energy company, they have existing infrastructure. The market is highly fragmented with small vendor specific applications. Now, I would say in recent years, it's not small vendor. For example, right now, Samsung is offering services, as I said, that refrigerator, washer, dryer, and everything is connected kind of thing. But what is happening? Everyone is reinventing the wheel. After Samsung, small companies will reinvent same type of services they will provide. So what we need to do is we need to make an end-to-end platform which have common services capabilities layer, right? And that has converged ICT infrastructure and M2M or IoT devices. M2M is machine-to-machine devices. So what is the benefit of this is, what we want to achieve is, we want to achieve seamless interaction between heterogeneous applications. That means different applications and different devices. Let me give you an example of healthcare system. So in the current healthcare system, for example, for stress disorder, healthcare providers need to collect data about patients, right? What they will do is they will measure maybe heart rate, blood pressure, sleeping profile to see how much stress and why there is stress in this person. However, we believe that this is very important to see the correlation of these things with the living condition of that person that can be achieved through smart homes, with the working conditions of that person, smart enterprises, with the pollution and noise in the city, smart city, and the condition of public transportation system and their effect on individuals. So my point is, you should not consider only one specific set of parameters. However, you need to find correlation with other parameters, other things as well, in order to correctly treat a person. So in summary, for IoT, first is we have exponential increase in connected devices and data generated. So that means we have huge amount of data. Now, next is we want this data to be communicated, to be transmitted. Sometimes, depending on the applications, data can be transmitted in real time as well. So that means communication capabilities should be very strong. And after that, when we collect data, we want to analyze this data. So thanks to the rapid development in the field of artificial intelligence and machine learning, now we can analyze and visualize data in a very efficient way. So building on this, what I mean is, in my area of research is wireless networks. So I'm more focused on this part. I'm not expert in analytics part, but I'm more I have expertise in this part, communication part, and to some extent sensors management as well. So future wireless networks beyond 5G and 6G, they are expected to provide unlimited connectivity to a growing number of heterogeneous devices. So this is the target. We want to provide connectivity to heterogeneous devices and a large, massive number of heterogeneous devices. So that's why in the title I had massive connectivity, that we need to provide massive connectivity. So as I mentioned before, in this book, we try to cover all these aspects from sensors to data analytics part. So overall, if I talk about challenges for IoT, scalability of IoT is one of the key challenges. Quality of service. Now, quality of service is very important, especially as most of you guys are from computer science background. So quality of service previously, when we talk about cellular technology, most of the users, they are concerned only about data rate. We want very good speed, right? We want more bandwidth. However, in IoT applications, I mean, some devices may need to transmit only a small amount of data, right? So they may not be data hungry applications. Similarly, from the spectral resources, now when we say we have massive number of devices, so when they are communicating wirelessly, they are using some type of frequency. Now, frequency is a natural resource. You have a limited number of frequencies available to communicate on. So how to manage that frequency efficiently, that's another challenge. Now, in some applications, actually in many applications of IoT, your devices are energy constrained. They are battery operated devices. So we want to manage energy resources efficiently. Then interoperability, as I given an example before, that systems should be interoperable. Samsung refrigerator should be able to work with LG dryer and washer and other appliances. Standardization, this is one of the key issues. Who will standardize the protocols? Then security and privacy, this is, I mean, maybe you guys at the end of my talk will talk about this as well, that this is the key challenge. Wherever I go, this is the hottest topic, that how you will ensure security and privacy, right? So this is the area where you need to uh, be focused on, that where a lot of research is needed. Then when I say global reach, this is again connected with my research area. So when I say global reach, it means you should be able to provide connectivity anywhere and anytime, in the remote areas, in the regional areas. Even in Canada, there are some highways. I don't have that map right now with me, but there are some highways where there is no coverage of cellular network, because because of the geographically, Canada is a very big country. So where there is no population, there is no connectivity. So if, for example, last year there was an accident of school bus there in that region. So that can be a very challenging sometimes. So how you can provide connectivity in the remote and regional areas, that's also needs to be investigated. So with this, with these challenges, my research focus is more on resource management schemes, where we say that we need effective resource management schemes from in future wireless networks, mainly because of three main challenges. One is there are massive resource constrained devices. As I said, that most of the IoT devices are resource constrained. Sometimes energy is a constraint. Then they have a diverse quality of service requirements. Some applications may need high data rate, high reliability, real time. Some may need low data rate but high reliability in real time. So diverse range of quality of service requirements are there. And a high density of heterogeneous devices. There are different types of devices there. Now, although there are many people working on in this area, still I believe that we need to develop some sophisticated approaches for sustainable networks. What I mean by sustainable network mean, actually, let's make this word self-sustainable network. Self-sustainable network mean a network which operate on its own. Maybe energy harvesting, in terms of energy, we need to charge the devices automatically. We don't want to change the batteries. Network should be operated on their own. So therefore, we need novel resource management schemes with constraints on connectivity, quality of service requirements, coverage, which should be able to cope up with the challenges of massive heterogeneous devices. So this is basically the main emphasis of my research program, which I'm running here at TRU, Thompson Rivers University. This is the main emphasis of resource management while considering these constraints and providing connectivity and dealing with the challenges of massive heterogeneous devices. So with this, I'm done with my first part. We have, Dr. Arun, we have both options. We can take questions from the part one now, or we
Okay, sir.
want to take questions at the end.
Yeah, thank you, sir. So if you want, I can take the questions. I will read the questions for you, sir. We have first question, which is from Imran Alam. What are the enhancements in 5G or 6G in respect of 4G?
What are the enhancement in 5G and 6G?
5G or 6G with respect to 4G.
Okay, so up to 4G, basically, when we started from 1G to 4G, there was only one challenge in front of us: provide broadband connectivity. if you see the pattern from 1G to 4G in each technology, the only focus was on the data rate, provide better data rate, more bandwidth. With the advent of this IoT technology, as I mentioned before, now we have a diverse range of quality of service requirements, right? So we we are not only limited to only broadband applications. As I mentioned, for example, in the case of smart metering, we need only a small amount of data to be transmitted. So the problem is, if we do changes in the 4G network, which is not inherently designed for which was inherently designed for broadband communication, not for small amount of data transmission, we will lose a lot of resources. So that's the reason why we need to move on to 5G, 6G. Another reason is, let me go to, okay, I think I will talk about this later as well. But another reason is we need to provide coverage to massive number of users. We need to provide connectivity to massive number of users. So one is to accommodate diverse range of quality of service requirements from users. Another one is provide connectivity to massive number of devices and manage your spectrum resources efficiently. And there are many more reasons we are moving from 5G and 6G.
Thank you so much, sir. And another question we have is, the participant is interested in knowing the use of IoT application in emergency rescue.
Emergency rescue.
Yeah.
So there are plenty. For example, in the case of disaster management, we did one project on this thing. That in the case of disaster management, what we can do is we can deploy sensors in the disaster area. And with the help of new technology, these days we are talking about UAV assisted networks, unmanned aerial vehicles network. So what we can do is we can collect data from there and do analysis. We can provide remote healthcare services to those people in the disaster affected areas. We can also, for example, we developed one application in the past, which was for industrial workers. So in most of the cases, when people working in industry, especially the labor workers and working in industry, they are not aware about the dangerous situations. So what we did is we developed a jacket and a helmet for industrial workers. When they go into a specific situation, if there is any dangerous situation occurs, it will notify them, okay, you need to evacuate from here, right? So that was the application we developed. I will talk about this more.
So one more participant is interested in knowing the difference between normal IoT devices and heterogeneous IoT devices.
So when we say heterogeneous IoT devices, heterogeneous mean different types of IoT devices. So heterogeneous is doesn't mean that a specific IoT devices. Heterogeneous, for example, we have one IoT device which has, let's say, temperature sensor, which has humidity sensor, and another type of IoT device which has GPS sensor, and different type of sensors are installed in that device. So when we call them together, we will say, okay, we have different types of IoT devices in this network. That means heterogeneous devices.
Yeah. Now I can say a very appreciation comment to you, sir. Great presentation, and the participant is interested in knowing that how will you explain the concept of a smart city to a layman, not to a technical guy. If the person in front of you is a layman, how we can explain the concept of smart city to that layman?
Okay. So for the layman, as I mentioned in my slide, what we can tell them, uh, recently I was a presenter somewhere where there were non-technical people, And when I presented the concept of smart cities to them through this slide, let me go back on the smart city, this one. So I told them we deploy more sensors. This can help you manage infrastructure and provide better services to the customers. They had a lot of questions. One example I can give you is a couple of examples. One is, for example, again, in terms of Canada, as you know, the weather is very harsh. If you need to go in the winter early morning to the bus stops, and you need to wait, let's say the bus is supposed to come at 7:30, but due to weather, it is 10-15 minutes late, right? So in that case, you need to stand on that bus stop for next 10-15 minutes in that cold -25, -30 degree, right? So with the help of, if you equip your buses with the GPS sensors, and in real time we can monitor them where they are right now, right? So in that case, what we do is, now if I put in the Google map, okay, I need to go this place, it tells me in real time where the bus is and when should I leave my home. It will tell me, okay, at this time, if you leave from home, you will be able to catch bus. Another example is, which is good for layman, is when I was doing PhD in Korea, there was a grocery store, Indian grocery store. So what that guy did is he put a lot of stuff in the warehouse, and there was no track record that how many I mean bags of rice I have, how many bags of flour I have, no information at all, right? So whatever is in running, he was able to sell that, and rest was piling up in the warehouse. Now after 1 to 2 years, what he figured out, most of the stuff was expired, right? It was a huge loss from his end. So if we apply IoT solutions in that case, where we manage our let's say stock or whatever we have in our warehouse with the help of sensors, with monitoring of temperature, with monitoring of humidity, that when they will be going to expire, even if you put, for example, if you have something which should be placed at the room temperature, if it is exposed to high temperature, it will even expire before the mentioned date, right? So with IoT technology, what it can tell me, let's say if the thing is going to expire in next 3 months, what I can do as a store owner is I can put that stuff on sale to get rid of that stuff. So with these examples, I think you can tell that with these smart city applications, uh, uh, mm, uh, the quality of life of residents will be improved. So yeah, I would say for layman, this is the best approach to give them real world examples.
Thank you so much, sir. However, there are a number of questions in the chat section I can see, but would request you to answer this question only, and then later on we will take the questions after the talk is over. How energy harvesting can be done in IoT?
How energy consumption can be done in IoT.
Harvesting is the word written over here. That I can
Okay,
see.
harvesting.
Yeah.
So I think I will talk about it in my talk.
Sure,
So
sir.
let me move on to the second part,
Yes, sir.
and then we will answer these questions.
Sure, sir. Sure.
Okay, so the second part is my recent research progress, and some I will discuss in detail some most significant contributions. Uh, so I divide my research contributions in four different parts. So one is the spectrum management, spectrum, how to efficiently manage the spectrum thing. Uh, in this case, we investigated distributed sensing, multi-band sensing. I will not go into the details of this thing, but Just to give an example, previously there was a dedicated spectrum for TV bands. Each TV bands take up to 6 megahertz bandwidth. Especially it is true in the case of North America, US and Canada, that, for example, if a channel is very popular in British Columbia, it may not be a popular channel in Ontario or in any other province, right? So in that case, that bandwidth is being wasted in another province. So what we want to do is we want to detect if someone is transmitting on that channel or not. If not, then we will use it. So this was the key concept of spectrum management, what we did. Then for the second part of my recent research is resource management schemes. So this includes resource management schemes to optimize the performance of IoT systems. This includes this paper was published in IEEE Network magazine, Emerging Technologies for Edge IoT Systems. So in this, we talked about both communication and computing resources. We talked about cloud radio access networks, wireless power transfer. I will talk more details about this. Device-to-device communication, energy-efficient optimization of IoT. So all this is related to how to efficiently resources. My key focus is energy resources and spectrum resources. Then what we recently started exploring is mainly the two topics we started exploring here. One is the machine learning for wireless networks. So we recently did a survey of this learning paradigms for communication and computing technologies in IoT systems. So what type of parameters can be improved through which machine learning algorithm? So you can find more details in the paper. And this is what I was talking about. Someone asked about that how in the emergency response systems IoT can work. So our recent paper talked about this energy efficient task scheduling and physiological assessment in disaster management. So what was the idea in this? So we consider that, let's say this is a disaster area where there is absolutely no infrastructure. So first thing is we deployed some sensors here. There are already one of the sensor node we can make through some cluster head selection algorithm. We made these yellow ones as cluster heads. So what they do is they collect information about the damage assessment, about the residents in that area. We can also send one or two doctors with smartphones and tablets. It can be nurses as well, which can go there. And through why I mentioned here phones and tablets, what they can do is instead of, because, it's more feasible, doctor is a very precious resource. Now, all of us realize this with this COVID situation. So instead of sending doctors, I would send some nurses, and what they will do is they will say, okay, remote treatment for these people in the disaster affected areas. These cluster head will collect data from everything, communicate with UAVs, and transmit to the data center. So doctors can be sitting in the remote area in a city where there is no, which is not affected by disaster, and still you can treat the patient. So this is one of the scenarios. So what we did in this case is, one thing is we make this basically how UAVs can collect data from the ground network, and then after collecting data, how we can analyze. So we analyzed based on different parameters. If someone is in very critical situation, then at the control center we can alarm, okay, we need to send maybe a helicopter or something to pick up that patient. Otherwise we treat them in a regular way. So this is a very good example of application of IoT in disaster management. So in summary, mainly my research is focused on spectrum management schemes and resource management schemes. Just to share with you um, that this is a bit old slide, so now the number of citations are even more. So how I, out of these publications, how I rate my most significant contributions, it's not based on publications, it's based on the topics. So I will talk about some of these. One, I think I did a very good contribution in cooperative spectrum management, then the resource allocation for IoT in cognitive radio networks, energy harvesting and wireless power transfer. I will explain the difference. What is the difference between wireless power transfer and energy harvesting? In sensor networks, I will explain this. And then there are two more schemes, that energy efficient IoT and distributed learning schemes for IoT driven CRN. So now I will talk more in detail about how we dealt with IoT challenges for the spectrum and resource management. Okay, now going into the first topic, let's first understand what is spectrum sharing. Where is my pen? Here it is. Okay, so when we say spectrum sharing, uh, if you see here, the blue ones are primary users. PU stands for primary users, and SU stands for secondary users. These are secondary users, and these are primary users. So you can take an example that primary users are, let's take an example of a house where the primary user is the house owner. So if the house owner is living in the house, no one can occupy that house, right? So what I'm saying here is, on the x-axis, if you see, it's a frequency resource, and on the y-axis, it is time. So if at time t1, primary user is present at this frequency, let's say f1, let's say this is f1. So secondary user cannot come and start operating in this frequency. However, if let's say at frequency f3, primary user was not there, so primary user can sublease, like rent that spectrum to a secondary user with an agreement that if I come back, you need to vacate this channel for me. There is another possibility. If a house has two portions or a basement, what we can do is we can stay together, primary user and secondary user, with the condition that secondary user will not interfere with the primary user. In normal case, in the housing example, the secondary user will not make will not interrupt the primary user, or will not listen loud music or this type of thing. In the case of frequencies, it means you will not operate on power higher than a given power threshold, so that you will not be interfering with the primary user. So this is the basic example, and cognitive radio technology is the basically behind it, how we can use spectrum dynamically. This is called dynamic spectrum sharing as well. So cognitive radio technology is envisioned to address spectrum congestion and push spectrum sharing in wireless networks to new frontiers. So basically, in order to accommodate more devices, a large number of devices, we cannot create new frequencies. Although people are investigating millimeter waves or very high frequencies, but that is also an existing resource. We cannot create more frequencies, so we need to manage these frequencies efficiently, how to use them efficiently. So by managing them efficiently, we can have more spectrum. Not that we can have more frequencies, we can have more spectrum by managing them efficiently, and we can have a higher efficiency. That means 1,000 times higher than if we like if we manage the spectrum in a traditional way. We can achieve 1,000 times more efficiency. Now, for the first contribution, I would like to talk. This is another example of heterogeneous network. What I mean by heterogeneous network is, no, spectrum sharing is not frequency multiplexing. Spectrum sharing, frequency multiplexing is something different. Frequency multiplexing is that that concept is completely different. So for the cooperative spectrum management, I will try to explain it here what spectrum sharing is. The existing literature, when we did this work, at that time, the existing literature said that, okay, what we need to do in the case of cognitive radio, what we need to do is we need to determine if the primary user is present or not. So what we need to determine is, let's say 1 and 0. 1 is if PU is present, and if PU is absent. So each secondary user, what they will do is they will sense the spectrum using some detection algorithm and see if the primary user is present, stay quiet. If primary user is absent, then start transmitting, right? So in the existing literature, what they were doing is they were considering that all the users have same type of detectors. So there are 4 main type of detectors in the literature: energy detector, cyclostationary detector, pilot-based detector, and OFDM-based detector. Again, I'm not going into the technical details of these detectors, but the existing work only considered that all the users are equipped with energy detectors, or all the users are equipped with pilot-based detectors. But as I mentioned, one of the key challenges of IoT is it is not necessary that all devices are of same type. Excuse me. All devices can be different. So what we considered is we considered a very realistic scenario where if you can see here, that some users are energy-based detector, some are pilot-based detectors, some are cyclostationary, some are OFDM. So this makes it a heterogeneous networks. That means different types of devices are there. So what we did is we developed frameworks for hard and soft combining. I will explain what hard combining and what is soft combining, in which the local sensing results from heterogeneous detectors are combined to improve the sensing reliability and detection. Now let me explain what I mean. So let's say here is a primary user. We are sensing this. All these devices are sensing this. Let's say this pilot-based detector senses that, okay, user is present. This detector says user is absent. This says user is present. So maybe the green one is making a mistake in detection, right? Maybe it is making a mistake. If we just rely on the local decision, the problem is it may lead interference to the primary user. So instead of that, what we do is we say, okay, instead of just deciding based on your local result, just send all of your results to this FC. FC is fusion center, a central entity. This one is saying 1, this one is saying 1, this one is saying 0. Now hard combining says that we have information in terms of 1, 0, 1, 0 from the secondary users, and how to combine them. There can be different rules. For example, there can be AND rule, there can be OR rule, there can be majority rule. So AND rule is if all the devices should say that primary user is present, only then I believe that primary user is present. OR means if any one device will say primary user is present, that means present. Majority means we will go with the majority voting, right? So this is called hard combining. In the soft combining, what we do is, instead of sending over result, instead of computing over result here that, okay, I decided that it was 1. For example, in the case of energy detector, we measure the energy of the primary user signal and see if it is greater than a threshold. Then we decide that if it is greater than threshold, primary user is present. If it is less than threshold, then primary user is absent, right? So in soft combining, what we say is instead of sending your decisions one in terms of one zeros, send your test statistics, send your energy levels to the fusion center, and then fusion center will combine it. So let's see what were the results. Now, in terms of results, I will try to explain them. So in the first one, if you see, we are discussing impact of heterogeneous detectors in detection performance in hard combining, that how it is affecting in hard combining. So if you see here, we considered that there were total 8 users sensing the channel. One of them was energy detector, 3 of them were cyclostationary detector, 3 of them were pilot-based detector, and 1 of them is OFDM detector. The performance is best. However, in this case, when we have more energy detectors, no cyclostationary detectors, no pilot-based detectors, only we are relying on energy detector and OFDM-based detector, the performance is really poor. This is probability of detection, that how much is the accuracy of detection, how much accurately we are detecting that primary user is present or not. So here is the importance of having heterogeneity in the network. Then again, in the literature, what we saw is everyone assumed that for the case of cyclostationary, everyone assumed that we have perfect received signal. What we figured out is, if you see in these curves in the graph 1, let me change the color. In the graph 1, if you see, the more cyclostationary detectors we have, the better the performance is. However, practically there can be some offset, cyclostationary frequency offset can be there. Now, in the case of, if you notice here, in the case of we assume 0% offset, probability of detection is almost 1. However, if we consider only a 3% or 5% offset, the performance degraded a lot, right? Performance degradation is lot. Excuse me. So a lot of performance is degraded. Okay. So in this case, what we found is that performance is highly dependent on what type of signal and how much accurately we are receiving that signal. Similarly, in the case of soft combining, when we said that send the test statistics, same thing we noticed that if we have this more cyclostationary detectors, the performance is better. If less, the performance is worse. And same is the impact on the frequency offset. Another thing, another approach is now in the case, although in the case, if we compare the both hard combining and soft combining, the soft combining wins. However, in the soft combining case, we need to transmit more data, right? We need to transmit more data. That means more bandwidth is required. So if we want to go in between, what we can do is we can quantize. Instead of saying that I am deciding 1 0, what we can say is we can decide that based on 2 bits. 0 0 means I am very sure that primary user is not there. 1 1 means I am very sure that primary user is there. 0 1 is I'm not sure, but my vote is near to that primary user is absent. 1 0 can be that my vote is near to primary user is present, but I'm not sure. So with more bits, what we can do is we can make a fuzzy decision. We do not need to say a hard decision that's 0 or 1. So the existing literature was restricted to 2-bit and 3-bit quantization. So what we thought is, how about investigate it in more detail and see if we further increase the number of bits in quantization, the performance improves or not. So we proposed a joint quantization and confidence-based generalized combining scheme. So based on the confidence levels of secondary users, and using a fuzzy logic membership function and weighted coefficient, we decided that primary user is present or not. So the key thing I want to tell you in this case is that it is clear from here that hard combining or rule. Remember, or rule is if anyone is saying yes, that means yes. Performance is comparable to soft combining. However, the important thing to note here is the soft combining performance is somewhere here. So if we have 5-bit quantization, the performance is very much close to the soft combining. So instead of sending all that data, what we can do is we can transmit only 5 bits, right? So with less data, we can achieve the same performance. This is evident here from here as well, that the performance with the soft combining is this one, this red curve, and with the proposed scheme with 5-bit on 5-bit, the performance is very nearby. Right, so this is what we achieved in terms of cooperative spectrum sensing. The outcome of this contribution, we published 2 papers in this. One is, both of them was published in IEEE Systems Journal back in 2018. Now, moving forward, resource allocation for IoT in cognitive radio networks, how we do resource allocation. Arun, how about if I take 2-3 minutes break?
No worries, sir. No worries. You can take your
Oh,
place.
thank you so much, everyone. I will be back.
Sure, sir. Sure. Participants, you can also take a break of 2-3 minutes. But be logged, remain in the system only. Welcome, sir.
Okay, let's start. Okay, so now moving to the second thing is resource allocation for IoT in cognitive radio networks. I believe this one will be more related to the computer science people. Uh, so what we did is we proposed a cross-layer resource allocation where we dynamically uh, change the parameters of different layers to meet the quality of service requirements. For example, again, let's take an example of this smart home. What we did is we said that mm, okay, so we said that in this case, there are different type of applications in smart city. Some applications, so instead of dividing the applications in terms of like smart parking or this type of applications, we divided the applications into different service classes. So first service class is which requires a type of application which requires high data rate and real time. Then second service class is low data rate and real time, high data rate, non-real time, low data rate, and non-real time. So different applications are there for all these service classes. So based on this, we set these parameters. For RD is the data rate requirement. Since it's high data rate, we assigned 3 to this one. It's low data rate, we assigned 1. So 0 means no importance, 3 means most important. Since it's real time, so latency is the most important. This RE is reliability. This is economic cost. So since we want a high data rate and real time services, uh, we are willing to spend money on these type of applications. Then how much this type of technology can affect the environment? So we also considered environmental impact. So based on this, we basically what we did is we designed a utility function and proposed a game theoretic approach to solve this problem. So what we did is, again, what we did is depending, we collected the requirements from the users. Based on that, we sensed the radio environment. We saw that, okay, these are the channels available. Then we run an optimization problem, and based on this optimization problem, we changed the parameters of different layers. For example, at physical layer, we changed the CR module, cognitive radio module. We can change their frequency. We can change their transmit power. At MAC layer, they can select the network. For example, depending on the requirement, we may assign them cellular network, Wi-Fi network, within a network, particular channel allocation, and at application layer, it is related to changing the quality of service parameters. So I will not go into the details of these results, but the thing is, what we concluded from these results is uh, we assume that there are 400 IoT nodes, and in each scenario, 25% of IoT nodes are from each service class, which I explained in the previous slide. So what we figured out is, now instead of treating all the devices of the same type, giving them very high data rate, we are treating heterogeneous requirements from IoT devices, different requirements. And our scheduler is very good and assigning resources according to the requirements of the users. Not, for example, if someone is needing low data rate and do not need much bandwidth, we will not assign the cellular technology to that user, cellular band to that user. So my point is, we efficiently manage the resources based on the user requirements by changing the by using the cross layer approach. In cross layer approach, at each layer we change some parameters. The outcome of this research was main outcome was this resource allocation for IoT in cognitive 5G networks. It was published in IEEE IoT Journal in 2018. So based on this contribution, I would like to mention that now I am participating in a IEEE Standards Development Committee as well. Now, lastly, the contribution, as someone asked before, what is wireless uh, energy harvesting in IoT? So basically, let's first understand what is the difference between energy harvesting and wireless power transfer. So energy harvesting is, thing, let's say this is a sensor node. Uh, we have solar energy resources available. We have, let's collectively call them renewable energy sources. So in the case of energy harvesting, we harvest from ambient sources. Ambient sources mean, let's say solar is an ambient source. We are not sure if it is available or not. On a rainy day, it's not available. uh, Wind is a renewable energy source. Someday it's more wind, other day if there is no wind, we will not be able to harvest energy from the ambient sources. When we talk about wireless power transfer, we have dedicated sources. We have dedicated sources which can wirelessly transmit power. So it is always available, right? It is always available. There is no point of saying that okay, it's not sunny, so ambient sources are not available. So we investigated the problem, basically two problems. One is the optimal placement of these wireless energy transmitters, and the other case is energy efficient scheduling of energy transmitters. So let's go into the detail of this, that how we did this. So we consider this scenario where we have, if you see, we have ambient sources as well. Ambient sources can be solar energy, wind energy, these type of sources. On the other hand, we have these dedicated energy transmitters which can wirelessly transmit the power, right, to these sensor nodes. Sensor nodes are IoT nodes. Now there are two challenges. One is uh, the optimal placement of energy transmitters, and the second thing is how many energy transmitters we should place. We want minimum number of energy transmitters while satisfying the user requirements, satisfying the requirements from all IoT devices. And then after deploying these energy transmitters, one approach can be they are always turned on, whoever, like our base stations in cellular networks, and whoever wants to communicate, they start communicating with them. That will definitely waste more energy from the energy transmitter's perspective. So what we proposed is, we said that instead of uh, okay, I don't have that scheme, but it's in the paper. So what we said that instead of after deployment, instead of talking directly, sensor directly talk to the base station. Sensor first send a message to a central entity that I want to harvest. So this central entity is aware of the location of sensor node as well as energy transmitter. So all the energy transmitters. So based on the locations, it will choose the optimal energy transmitter for the sensor nodes and send a message to that energy transmitter. Now you can turn yourself on to transmit energy to this user, this particular sensor node, right? So in this case, for example, if only this sensor node is requesting energy, so maybe we need to turn on only this energy transmitter and these two are off. So we are saving energy. Another sensor node in the close vicinity is requesting, so no need to turn on additional energy transmitters. right? So our results indicates, first thing is our results indicate that how much energy transmitters we should have, depending on um, the number of sensor nodes. And we defined an error margin that, okay, if someone is requesting that I need to charge X amount of energy, if even if we charge X minus eta amount of energy, we should be fine, right? So these alphas, okay, now when we say we want to deploy energy transmitter, it can be deployed with op, different objectives. For example, one objective can be we want overall network energy harvesting maximization. What will happen in this case? If most of the sensor nodes are sitting in this area, in one particular area, we will just install energy transmitters in that area, and overall network's charging is maximized, but a node sitting here may not be able to charge. So other approach can be the fairness. So it should be fair for everyone. So we considered a trade-off between fairness and energy maximization. This alpha 1 and 0 is a difference between maximization and fairness thing. Then how to schedule energy transmitters? We noticed that uh, according to our scheduling scheme, we are our results are compared to exhaustive search scheme, and also we are consuming much less energy as compared to traditional wireless sensor networks where the energy transmitters are always on. So the request from IoT nodes or sensor nodes, we call them tasks. So if there is no task, that means there is no request for charging. That means we are not consuming any energy from the energy transmitters, right? So depending on the tasks, the energy transmission, if you see that we consider the case for tasks, no, total number of tasks 5 and 15. So if you see, if it is the traditional case, the energy consumption is linearly increasing. However, in our proposed scheme, maybe some tasks are coming from the close vicinity IoT nodes or sensor nodes, right? So in that case, you don't need to turn on a separate energy transmitter. So you can clearly see a huge amount of energy saving here. The outcome of this research was published in IEEE Sensors Journal in 2016, and the conference version was published in IEEE PIMRC, which is a prestigious conference in IEEE. And our work, this work was listed as most downloaded Sensors Journal paper in September 2016 among all the Sensors Journal paper published since the journal's foundation, which is a great achievement, I would say. So just to give you a brief overview of rest of two main things, energy efficient IoT. Basically what we did is we proposed an optimization framework for IoT-enabled smart cities. We found that existing literature on energy and spectrum-efficient IoT, they did not address energy-aware mode switching strategy. Basically, energy-aware mode switching strategy is based on energy. We change our strategy and increase the lifetime of the network, as well as channel allocation for stability. That means more stable connection, as well as reliability. So this work was published, the framework was published in IEEE Communications magazine, and a mode switching strategy was published in IEEE IoT paper. And lastly, with the help of one of my master student, which I was to whom I was mentoring, she was in University of Carleton University in Canada. So she proposed distributed learning strategies for multi-band sensing. So again, we have very good outcome of this work. Again, the focus was on heterogeneous networks, scalable networks, which, if you recall, when I was discussing the challenges of IoT, scalability, heterogeneity, performance enhancement, different types of quality of service requirements. These were the major challenges. So I mean, for all these techniques, we are trying to address those challenges. In addition to this, as someone asked that what are the practical applications of IoT as well. So just to share some practical applications which we developed here. So in last summer, with the help of one student, what we did is we developed an IoT platform for food transparency and traceability in food supply chain. So what does that mean? Let's try to understand this. So what happens is in a food supply chain, the food starts from the producer, then transported to the manufacturer, from manufacturer again transported to the warehouse, from warehouse it can go to retail store. There can be other phases as well, but let's assume we have these phases. So what we proposed is, actually this is already in literature. What we did propose is, I will explain it. So what we did is we equipped each food item which is to be shipped from producer to manufacturer. We equipped them with RFID tags, and with RFID tags we put them in the let's say this truck, and in this truck we have a temperature sensor and humidity sensor and other GPS sensor is there. So we know that which route it is following, what was the temperature during the transportation, was it mishandled during the transportation or not. So this type of things. So this was already existing in the literature and people already developed these solutions. But the problem was with this type of solution, let's say if someone during this whole cycle mishandled the food, when it reaches to retail store, what someone can do is maybe producer or manufacturer can go into the database and change, modify the values there. So what we proposed in our architecture is, if we make this database blockchain enabled, then what we will do is, what will we can achieve is, nobody will be able to change the parameters in between, right? So what we achieved in this case, we developed a mobile application at the retail store. When a user will come to buy an let's say milk or meat, they will scan it and they will see, okay, from producer to retail store, was this product mistreated? I mean, it went on a high temperature or not. So the user is well aware of all the production cycle. So this is a small scale application, but let's think about the application where the food is transmitted from one country to another. So this is extremely important in that case to measure what was the temperature and other related parameters while transporting those stuff. Another application of IoT, uh, 3 years back, my son started going daycare in here in Canada. So when I used to drop him to the daycare, each teacher was responsible for 6 or 7 students, 6 or 7 kids. So she need to enter what time this guy is coming, what time he's sleeping, what time he's up, what time he's eating, for all the kids. So what I thought is, okay, she is already overloaded. She maintain record or she handle kids. So for that, from that perspective, and also from the parents perspective, like usually they take kids for a walk 2 times in a day, in the morning and in the evening. And in the evening, when I used to go pick my son up, they tell me, okay, today we went here for a walk, or today we went there for a walk. So what I proposed is, how about we build a smart wristband for kids, which is equipped with RFID technology as well as GPS sensor is there. So what will happen in this case, when the kid will go into the daycare in morning, instead of teacher note the time, He just need to tag the wristband with the RFID reader, and attendance is marked. Similarly, this band is directly linked with the portal, which is accessible to both parents and the staff. So if they go out for a walk, since GPS sensor is there, as a parent, I can monitor that where my son is going during the day for a walk, what route he is taking, and we added several other parameters in it. And this is another very important example. Excuse me. So this is context-aware IoT application to support industrial workers. So basically, in 2015, statistics from the Association of Workers' Compensation Board of Canada, they told that, okay, there were 852 workplace deaths were recorded in only 1 year. So the reason is workers are overloaded with the information, or sometimes they are not aware of the dangerous situations. So what we did is we developed a jacket and a smart helmet for them, and for all their tools we equip them with RFID tags. For example, if the worker receive a job to fix gas leakage, and if he tries to pick a wrong tool, the application will immediately notify this is not a right tool. If he is expert, he should know what is the right tool. Anyway, right tool is picked, went into the situation. Now there was gas leakage, and inside the jacket there was a sensor which detects gas, and it immediately notifies that you need to evacuate this place, right? So this is one of the applications undergraduate students developed. Now finally, I will talk about what we should do as a researcher in long term. As I mentioned before, long term means in next 20 years, short term means in next 5 years. So if I talk about myself, my long term goal is to continue developing resource management schemes to tackle the challenges of seamless. Seamless means if even if you are shifting from one technology and to another technology, we should not be worried about it. And high quality wireless connectivity of heterogeneous devices anytime and anywhere. So that's the key motivation, that provide connectivity. As I mentioned before, even in Canada, there are some road infrastructure where there is no connectivity of cellular communication. So we need to look how we can provide connectivity in remote and regional areas and in those highways. So I think I have those maps here. So this goal is in line with the Canadian Radio, Television and Telecommunication Commission. So their objective is that every Canadian should have minimum 50 Mbps download speed and 10 Mbps upload speed, and access to unlimited data. There should be no restriction. So right now, if we talk about Canada, 85.7% Canadian have this facility. However, in rural communities, only 40.8% users have this community. So that means a lot of work need to be done in rural communities. So this is road infrastructure. For example, major roads without LTE. So you can notice there are several roads in blue color where there is no uh, cellular coverage, and these red ones are inhabited areas without LTE. So there are people living without communication. So there are communities without high capacity transport. Satellite dependent communities are there. There are communities, the green color, where they are not able to have 50 Mbps download and 10 Mbps upload speed. So that means uh, if I talk about Canada, a lot of work need to be done. If I talk about India, a lot of work need to be done. throughout the world to provide better connectivity in everywhere to everyone. Now, if I come to short-term objectives, uh, so again, the objective is same, to provide connectivity to a massive number of devices to support substantial traffic demands and expand coverage. So in order to expand coverage, basically I divide it into short-term objectives into three things. The first thing is to develop predictive and context-aware resource management strategies for future terrestrial ground wireless networks to efficiently serve a large number of heterogeneous devices. So that means predictive and context-aware resource management schemes only for these ground networks. The second thing is investigate low complexity schemes for on-demand deployment. What I mean by on-demand deployment of aerial networks, for example, let's say we are having a big gathering, a cricket match or some big gathering is going on where we need to provide connectivity, right? So on demand, we can send UAVs, unmanned aerial vehicles, to provide connectivity there. Also, in the literature up to now, people are optimizing resources. Even, excuse me, even myself, my focus is previously was only communication resources. Now I started investigating computing resources. However, control resources are there as well. So my point is we should jointly optimize these resources rather than treating them individually. And last thing is, in short-term objectives, is to enable seamless integration of wireless information and power transfer. So for that, what does that mean? If I'm going with a mobile phone, I should not be worried about should I charge it or not. It should automatically be charged. Also, we want network intelligence for self-sustainable aerial and terrestrial networks to enhance key performance indicators. So we want to add machine learning and artificial intelligence algorithms to further improve the performance of the network. So in summary, uh, my recent research in the area of communication networking for IoT has led to the development of spectrum sharing and resource management schemes. Um, Building on this success, my motivation is to continue developing resource management schemes for massive connectivity. Uh, Basically, the objective is to carry out performance evaluations via simulations and compare proposed work with optimal results in the state of the art literature. Uh, the ultimate objective is to provide benefits to the users and society. So if they are getting a better connectivity, reliable connectivity in dense environments, in remote areas, that's the main objective. So overall, this proposed research in the short-term objectives, this will definitely improve the resource management for massive connectivity. And also it can provide recommendations to 3GPP, which is basically the standardization body of this 1G, 2G, 3G, and 4G, 5G, all these standardization body. And we can provide recommendations to 3GPP for beyond 5G and 6G networks. So that's all from my side. Thank you so much. Now I will take your questions. This is not the correct email ID. Let me put the correct email ID here. Waleed.ijaz@ieee.org. Okay, now I will take your questions.
Thank you so much, sir. Thank you for such a wonderful session. And I must say one thing that today you have touched upon that area of IoT which was untouched during this FDP. The speakers would discuss the concept of IoT, but not in that depth, I can say, or how beautifully you were able to cover the application areas of IoT in day-to-day life and the research directions as well you covered. So you can see so many appreciation comments are there in the chat section. A very informative session, excellent
So much.
session,
Thank you so
wonderful
much.
session. Yeah. So as we are open for question answer session now, let me read the questions one by one, and I will start reading the questions from the top. Means it's the questions we had earlier also.
Sure.
So I think we can start from yeah, this one. This one. How IoT can help to meet the infrastructural needs of education industry during lockdown period as well as post COVID era.
Oh, very difficult question. So, if I talk about in general, I will come to the specific educational sector. In general, I can see a lot of post-COVID applications of IoT because many people who were reluctant to do online shopping, for example, before, now they are doing online shopping, right? So there is a terminology that now it will be uh, X to home. IoT will help to achieve X to home. X can be anything. X can be anything you think of that will provide it at home to you. So X to home services will be post pandemic situation. Now, in terms of educational sector, one thing I would say is that those people previously I met several people who were against this online teaching thing. Now they have to move on to online teaching, right? Forcefully they have to move to online teaching. uh, I mean, in terms of educational sector, uh, I need to think about it how we can particularly how, because when we talk about IoT thing, we need to deploy sensors. So in the educational sector, if we are talking about the students improvement, uh, I don't know how we can deploy in their homes. That's beyond our scope to deploy something in their homes. One application can be, for example, one thing we have faced during the examinations, online examinations, is there is no way to uh, accurately measure the performance of students. So maybe if we can come up with some strategy using IoT technology to measure the performance of students accurately, to take exams accurately. So this type of application, but we need to think about it.
Thank you so much, sir. And the next question is from Dr. Iti Huda. She says that you talked about challenges in IoT. What will be the negative impact of too much emergence of IoT in humans' daily life?
I'm not supposed to talk. I am promoter of IoT, so I'm not supposed to talk against it. But yes, there are several challenges. Uh, there are several challenges. For example, if we uh, talk about privacy concerns, for example, 2 years back we started one project with a hydro company. So this is here is another suggestion for people from academia, that we want things very sophisticated, and we want things to go into the things in a very detailed way. So while designing those strategies for energy management, energy efficient management of the system, what we were thinking academic point of view, okay, if we are able to get energy consumption of the home from different appliances and this thing, we can propose very sophisticated solutions. But when we went into the field, people refused. We are not providing you information from the home that will hit our privacy, right? And in case of a security breach, someone can someone can break our house, or someone can break in our house. So my point is, Uh, this is the reason why I would suggest all the engineers to do a survey and connect with the real ground realities first, right? So the negative impact, the what I can see is the privacy thing. That is the most negative. People think that their privacy will be on stake, and in case of a security breach, a lot of information will cause a lot of damage. I mean, another aspect of this is that when we have these small companies or even big companies who are collecting data from us, for example, Facebook or other social media applications, they collect a lot of data from us. We trust on them that they will not sell our data to anyone, right? But who knows, if any other company, not talking about any particular company, but if some small company, they collect data and they sell our data, what so these type of challenges are there which we need to. That's why I mentioned in the challenges the standardization, right? We must have standardization, and so that there is a way to collect data, and there should be no one selling our data or security breach and privacy things. Yeah, so these are the negatives.
Thank you so much, sir. The next question is from Faraz Masood, and this is related to the application you discussed earlier regarding the food supply chain. And the question is, what kind of blockchain you are using in food supply chain? Who mines the blocks and who owns or maintains blockchain?
So again, this was the work we did last year. We just proposed some blockchain technology. I'm not expert of it. The student is still investigating, because if I go back to that slide, this is not my area of expertise. So what we did is we implemented it without blockchain here, and the student is still working on this project, and he's trying to implement some type of blockchain. He's I mean, basically, we what we did is we made a web server on Raspberry Pi. So based on our discussions, it's difficult to have blockchain right now in the current form on some type of this type of modules. So it's still under process, and it's not my area of expertise, so I would not comment on it. Blockchain, as far as this communication aspect, RFID, how to communicate, I can comment on that part.
Another question is from Taibur Rahman, and he's interested in knowing that if there are two devices, one on Zigbee and one on another one is a BLE device, how can they be interoperable?
How they can interoperate?
Yeah, how they can interoperate.
So the thing is, when we say that heterogeneous connectivity, we say that, uh, for example, right now, I can use my cellular network phone to communicate with someone who is using cellular network. So right now, Bluetooth will be able to communicate with Bluetooth. The objective of future is that two devices should be able to communicate with each other. For example, if let's say in a smart home, we are using a refrigerator from a company which is operated on Zigbee, and again the example of washer and dryer, they are operated on the Bluetooth, right? The product is from two different companies. Now, since they are using two different communication technologies, they should not be able to talk to each other. Uh, we want to make this happen, to make this a reality. If I go back to that slide, So if I go here, it is that, for example, if some device, for example, the building, IoT system for the building is operated on Wi-Fi and energy system is operating. Let's assume that it's operated on Bluetooth or any other technology. The point is they should be able to communicate with each other regardless of what type of technology they are using. So this is what I meant, that Bluetooth device should be able to talk to Zigbee device.
Thank you so much, sir. Another question is, if you could please suggest some IoT data sets that need data integrity verification.
There are plenty. The one we talked about, the work I talked about, the IoT disaster management application, we took the data set. I can share a website with you. There are data sets available. There are plenty of data sets available. So I can share with Arun and
Yeah,
he can tell everyone.
sure, sir, sure. And another participant, Malvika Gupta, is interested in knowing if you could suggest some protocol among the different protocols, which which is the best for IoT.
Protocols for which layer? I mean, network
Lay,
layer.
yeah. She didn't mention any layer. She was just interested in knowing the best protocol amongst the various protocols.
Now the thing is with the IoT again, with heterogeneous devices, heterogeneous requirements, there is nothing, there is no one solution that fits everything. So I cannot say one best protocol for MAC layer, one best protocol for routing layer, one best protocol for any other layer, transport or application layer. So it, we need to come up with a solution, as I suggested, one cross layer solution in my approach, uh, where we are changing parameters at each layer. So we need to come up with this type of thing. For example, in if we are serving this application, we should use this protocol. If we are serving this application, we should using X protocol or Y protocol. So this type of solution we need to come up with. There is no one solution that fits everyone, everything.
Yeah. And now I can see only the appreciation messages. There are number of appreciation messages except of one common question, which is generally asked, and that is, can you share your PPT, sir, so that we could share it with the participants.
Sure, sure. I will share with Arun and he can give you.
Thank you so much. Thank you. So nice of you, sir. And we will send you a certificate of appreciation also, along with a poster of the feedback messages or the, you can see the appreciation messages to you, so that you can also post them to your social media handles. And with this, and in future, we would like to explore some collaboration opportunities if we can collaborate in one or the other way through our faculty
Yeah,
members or
especially, I would like to share here, especially for the undergraduate students, there is a program, MyTex program,
yeah,
in which undergraduate student can come here in summer for 4 months. So I would be happy to take students. They need to find an academic supervisor, so I would be happy to support their applications.
that could be great, sir. So, how many students can you accommodate in that program, sir?
um, I can support. I think they have limits to countries, so they have some quota to India. So I'm not sure how much, but if they want to apply, I can provide them support later. Um, so I'm okay to accept if 2 3 students are coming every year.
Yeah. So, what type of cost is involved in that, sir? Means they need to pay any tuition fees also, or they just need to pay their accommodation and fooding and lodging, etc.
No, nothing they need to pay. The Canadian government will pay everything.
Sure, I will definitely discuss the same with my higher authorities, and I'm sure that we can collaborate and we can start collaborating in this manner so that student exchange can be done. And thank you so much, Dr. Walid, sir, that you could spare time from your busy schedule and that too on the short notice. I know that what short and notice it was, and you agreed. to deliver a talk in this FDP.
No, thank you so much for having me. No worries, I'm here. It's knowledge mobilization, so it's good we talk to each other, we share knowledge with each other, support each other. So this is the only way we can move forward.
Thank you so much, sir, and so nice of you, sir.
Okay, thank you very
Good,
much, everyone.
good.
Thank you. Bye. Have a good day.
Thank you, participants. So the next session is at 2:30 today. So I request all the participants to be there at 2:15 sharp. Thank you, sir. Thank you so much.
Thank you.
Yeah. Thank you, all the participants.